All right. So we have studied about computer networks, right? All of you have studied about computer networks, where you got to know that computer networks is nothing but, the study which connects two or more autonomous devices, and those devices can be geographically located anywhere, right? So when we are talking about computer networks, we always think of in the terms of the internet. Okay, that means, what we have seen, what we know, and accordingly we try to make sense of whatever we are studying. That's how our human mind works, right? So what's the internet? It is basically millions of devices which are connected together. It can be PCs, servers, laptops, smartphones, etc. Okay, so we have different hosts, which have, different, which are basically different end systems which are running different network applications. And when we are looking at internet, so since all of you have done your computer networks course, you know that we have different ways of accessing the networks, and we form small networks with that. That means a small connection, or a small set of hosts which are getting connected together, and then they are further connected. So if you think mathematically, very small sets are getting connected, okay, and they are forming a very large set. Okay, so with this, so you have these networks, that is, this is your mobile network, this is a home network, that is what happens at your home, Wi-Fi access, or some of you are using LAN at home. So that is one network that you can have. Then how you see in your institute, that is different hostels are connected to different LANs, and therefore they are connected and they become a huge network, and further they are connected to a internet service provider. Okay, so then we have in the back end, we have the regional ISP, the global ISP, etc., forming the core network. Okay, so this is the backbone of the network, and these are the edges. Okay, that means the institutional network is an edge, the home network is an edge, the cellular network is, again, this is also forming an edge. Okay. So when we are talking about, connecting your device to the edge of this network, there are different ways in which you can connect. You can either connect wirelessly, or you can connect via a wired medium. Okay, so okay, just a second. So we have our wired links, we have wireless links. You can connect your phone or connect your device either via a mobile hotspot using your phone, or you can have it connected using your wireless access point. Okay, so when it comes to wired links, it can be used, it can be using, fiber wires, optical fibers, copper wires. And when it comes to wireless links, it can be either radio links or satellite transmission. Okay, so these are what we know about communication links. You might have also studied about transmission rates, which is basically different links can transmit data at different rates, and this rate is given by this transmission rate, is known as this transmission rate. Okay, and when it comes to the backend network, routers and switches basically form this backbone, and they are the ones which forward the chunks of data that you are basically sending as a user, or you want to receive as a user. Okay, so we call it as packets. when we are using packet switched networks, or in general as a very general term, we can call it as a packet. Of course, depending upon your switching technique, the way you are forwarding the data, or the way the data is being sent or data is being divided, that will change, as you all know. Okay. So very basic stuff here. So internet is a network of networks. It is nothing but interconnected ISPs. And we have already studied about protocols and internet standards in our computer networks course, where we have studied about TCP, IP, HTTP, etc. 802.11 is Wi-Fi, and probably you will study it when Dr. Manas is going to teach you wireless networks. Okay, so this is what about protocols. You know what protocols are. They are basically a set of rules which help in controlling the transmission of data between devices. All right. And where are they mentioned? They are mentioned in different internet standards. Those standards are given out by different international bodies. That is in Internet Engineering Task Force. This is also one of the international bodies that develops documents which are basically going to be standards. And these documents are nothing but they are known as request for comments, or RFC documents. Okay, so for different protocols, you will have your different RFCs. So if you want a further look on different protocols, you will go ahead and you will see what is there in these RFCs. Okay. So why are we looking at this internet? Because this is what provides you different applications, starting from your browsing, VoIP, email, your online games, e-commerce, social networking, etc. Okay, and they are all distributed in different user equipments, the applications. Okay, so these applications, they are the ones that involve different ways, or um, they involve different end systems and different ways of exchanging data with each other, depending upon what is the kind of access network they are using, what is the speed that that access network is actually providing, how many other users are getting served. So all of this, that is, see, until computer networks course, you have studied that what is the basic structure, how it looks like, and what are the different components in the OSI layer, in the TCP IP layer. That is, if I have to send a packet from one device to another device, what are the different protocols that this packet might have to go through. That's what you have studied in your computer networks course. Now, when you are coming to topics in networks, at least in this module, you will study further advanced parts of this. That means when you are going to send a packet, what are the other stuffs that are going in the interconnected parts also. Okay. All right. So let's get to the network structure, because from this we will go ahead to our next part, that is switching. So so as I was talking about, that the edge of this entire network, that is internet here, so it's fully interconnected nodes. So the edge is basically these parts, that is the clients. Okay, that means your phone, your laptop, your monitor, or any other device that is basically getting connected to the internet, that will form the network edge. Okay, so in order to connect to these or in order to connect these hosts to the network, we generally use different access networks. As we have seen, it can be either a wired network or a wireless network. And the network core, which is basically interconnected routers, those will form the backbone of your network, and they will be responsible for forwarding the data to the corresponding destination. Okay, so this you have already studied in your computer networks course. So basically, how do we connect the end systems, that means the hosts that you are having in your hands, to the router which is at the edge. Okay, so this is the router at the edge. Okay, so we have all routers at the backbone, and there is this router which is at the edge and which is responsible for taking all the data from these devices and then forwarding them to the corresponding routers, which you find out using the routing algorithm, that is what path they need to follow. Okay, so the most important thing is how do we send this data to this edge router. Okay, so there are different ways of accessing. So we have already studied that it can be either wired or wireless medium, but what are the different types of networks that can be formed with these different user equipments? Okay, so if you have read your basic computer networks Kuros and Ross book, then you might have seen that these are the different ways in which they have mentioned that you can have either residential access network, or you can have institutional access network, or you can have mobile access network. So let me just give you a brief description of these. So when we are talking about mobile access network, we are basically talking about cellular network. Okay, that is from your phone. All right, so when you're using your phone, you are either, nowadays I think everybody is using 4G, and we will quickly now move to 5G. Okay, so we'll start with this, and your phone needs to be connected to something, right? That will help you to make a call to somebody else, right? So what is that something? So this also, so we know that there are some base stations that basically help the phone to, your phone needs to be connected to the base station so that it's, you can receive phone calls, or you can send phone calls. Otherwise we say ki network is not there, right? If we don't get those bars in your phone. Okay, so basically the base station is the one that is acting as an access for your device. So your user equipment, or basically your mobile phone, is uh, required to get connected to the base station, and this base station will allow your phone to communicate either to the internet, or to communicate to another mobile phone for voice calls. Okay, if you are using WhatsApp call or any other Skype call, okay, any other voice over IP, in that case it will connect you to the internet, and then you can communicate to that particular person. So basically this base station, if there is something that is to be done using the internet, then this base station has to be connected to the to some edge router that will only send the data to further routers and to the corresponding destination, right? So this mobile access network is basically how, or what are the different ways in which a particular mobile phone or a particular device which can connect using cellular network. So those devices, how they can be connected to the base station so that that data can be further sent to the internet or via the backbone, and then the request can be served. Okay, so for example, from your phone nowadays you can watch movies, you can browse, you can do Skype, you can do games, everything you can do. So how is that happening? Okay, and you can also call, right? So that's happening with the help of this base station, which is basically connecting you to the backbone network. Similarly, when it comes to your Wi-Fi access at home, okay, so some of you right now, when you are, you know, doing this class or any other class that you will do today or in this semester, so you might be using some Wi-Fi access at home, right? So you can use some, either Airtel, BSNL, or some other local cable, or local cable operators also give Wi-Fi access, right? So those what do? They will simply provide you with a router at your home, and then this which is basically nothing but a Wi-Fi access point. So this access point will be responsible for taking all the data that your device is basically sending or requesting to get served for, and then it will forward it to the edge router. Okay, so sometimes these devices we call them as routers or we call them as access points because they are basically a combination of both. Okay, a switch and a router. Okay, and they act as an access point for taking and take all the data that your user equipment or that your device is basically sending, and then they will forward to the backbone network. So this is basically consisting of your residential access network, and then comes your institutional access networks, that is small networks that we form in schools and companies, etc. So we know how it works in our institute, right? So we have different hostels, and in each hostel you have LAN connections or LAN ports in your rooms. Okay, so if you have studied in your computer networks course how network address translation works, okay, so basically this institutional access network helps in working with that, and it is just forming a very small separate world of its own network wise, and it will be connected to a edge router. Okay, and that edge router is basically going to forward all of this data that is basically the outgoing or the incoming data um, from the users who are using this access. Okay, so this is what our institutional access is. Now, when we get into the network core, okay, we have to first start with that we know that what do we know about network core that we have studied in our computer networks course. Okay, so we start with basic switching techniques. That is, we just know that the core network is going to help us in forwarding the packets. Okay, so how it can do? It can either use the basic packet switching technique or circuit switching technique, or two other switching techniques, that is message switching or virtual circuit switching. Okay, so packet switching is the most general switching technique. Okay, so we do have interconnected routers in the backbone of the network, and we all know that in packet switching the host will break the data or the application layer message into small chunks, and these chunks are known as packets. Okay, so what is the job after that? So once this data is divided into different packets, then the job is to forward these packets from one router to the next. Okay, now we have already studied that this, how to find the path from the source to destination. This is using routing, etc. So this is all we know. So we have already studied that in packet switching we will forward the packets. Now these packet need to be transmitted at the full link capacity so that we can actually get the quality of service that we really want to. Okay. So now let us see that how to send these packets. So the host will send packets of data, and we have studied that it will be able to send the data depending upon what is the transmission rate that is being provided by the access link. Okay, so here as you can see, R is given as the link rate or link transmission rate between the host and the destination. Somehow this diagram is not coming very nicely. So this is the router and this is the host part. Okay, so this R is the link transmission rate between these two hosts. Okay, it is also sometimes called as link capacity or link bandwidth. Okay, but I would but the more correct term would be link transmission rate only here. Okay, now you have already studied that for packet transmission delay, the transmission delay is given by the length of the packet that you are trying to send, which is in bits, divided by the transmission rate. Okay, so that is given by L by R, where L is the length of the packet in bits. Okay. Now, there is one important principle that packet switching uses. All right, and that is the store and forward mechanism. Okay, so packets are sent from the source to the destination using the store and forward principle. What is it? That is, the entire packet must arrive at the host in between, okay, before it can be further transmitted to the next link. Okay, so since there are like a host, a source and a destination, and there is a router in between. So if this source is sending 3 packets, 1, 2, and 3, so packet 1 will arrive at this router. It can be further sent over to the next link only when packet 1 arrives fully at this router. Okay, until then it will be stored at this router. All right, so this is what your store and forward is, store and forward mechanism is. So these things you have done in your computer networks course, that is, how to find the end-to-end delay, assuming there's no propagation delay. And right now we are not talking about queuing delay right now, and not even processing delay. So basically with transmission delay, how much of end-to-end delay you are going to get. So this is only twice of L by R. And now let's talk about queuing delay, because this is what is going to be important in your course. So queuing delay, we know that packets will get queued at the hosts or at the routers in between when there is a surge of incoming packets. Okay, if packets are incoming or arriving at a router or any host in between at a very large rate as compared to how they are moving out of the node, so then they will form a queue. Now, if there is a queue of packets, that means the packets are basically going to wait for their turn to move out, and that will cause some amount of delay, right? So that is known as queuing delay. When we are going to study queuing theory, then you will see that how to find out this delay. Okay, that means how much time your packet will actually wait at a particular node on an average. So because in general, otherwise it will be very difficult to find out, right, how much time your packet will stay in a particular router, right? How many packets are basically going to be there? What is the expected number of packets which will be there or which will wait in a router, given that this is the amount of arrivals that is coming, this is the way in which packets are departing from this particular host. Okay, so these data will help you to basically finally calculate or analyze the system, that how your system is going to perform. So at the end of the day, for any internet service provider, okay, they have to find out, right, that if I have to provide some X Mbps of data rate to my customer, then given that this is the architecture that is there in between for my company, how much of waiting time will each packet get? Only then I will be able to know that what is the amount of packets that are outgoing from this system, and what is the rate at which it is outgoing from the system. And then you will finally find out that if I am promising my customer that I will give them X data rate, at least X data rate, that whether they are actually getting that or not. Because if they do not get, they will be unhappy and they will leave your internet ISP, or basically they will leave your company. So every company has to do such kind of an analysis. Okay, So it's very interesting once you actually get to know this. So let's see a bit further. So we all know that if the queue becomes very large, then you will face packet loss and packet delay. Okay, and this is how your entire sources of packet delay comes into picture. You have processing delay, you have queuing delay, you have transmission delay, and you have propagation delay. Okay, so let's see further. So this is all basic computer networks. Let's get to the next one, that is your circuit switching. So can anybody tell me what is circuit switching? You all know about it, so can we just get a few pointers on circuit switching? Nobody is interested in answering, or what happened? Somebody's video is on. Dilendra Uike. Please turn off. Okay. Yes, anybody? If you want to give an answer on, you all know about circuit switching, right? So
Ma'am, in circuit switching, the end-to-end path is decided, like allocated, and once the entire circuit is allocated, then the packets move instead of stop and go.
can you repeat? There's a lot of background noise. Can you repeat, Aditya?
Like the path is pre-allocated, the entire circuit is pre-allocated, and there is no stop and go between the routers. It is an entire, like a circuit is assigned from destination, source and destination.
Yes. Yes, that is the basic of circuit switching. Now you've already studied about packet switching also, no? So there must be some differences between packet switching and circuit switching. So apart from this, can anybody else tell me that what are the differences between circuit switching and packet switching?
Bandwidth is reserved in circuit switching and it is not reserved in packet switching.
Yes, but that's what he told, no, that there is a complete path that is given out. So that means you are reserving the resources there. Hmm? Anything else? One hint is I just told you different types of delays. So in terms of that,
There is no queuing delay in circuit switching.
yes. And in terms of how the data will be transmitted, so packet switching, with the name itself, you know that it will be divided into packets and then it will be sent. What about in circuit switching?
In circuit switching, the like stream of bits will be sent from source to client.
Okay. It seems you all know everything. So I did not teach this one. Okay. So let's see. So as has been already discussed, so in circuit switching, excuse me. So in circuit switching, we allocate end-to-end resources between the source and the destination. So it is based on, or basically this principle is what is used in telephone networks. Okay, so I will also teach you in this module that how or what happens when you are actually making a call from one device to another device. Okay, so this is what basically happens in a telephone network. Now just to give you a brief idea of this, so in older movies, no, Hollywood movies or something. Even I think if you have watched The Crown, so in that also you will see that when there is a call that was being made, then you would have to talk to an operator, and that operator would basically give you an access. You have to wait. So you make a call, you call to the operator, and then you tell the operator that I want to talk to certain person, which is this state or this country, and then the operator will ask you to wait. By then the operator will basically give you access to a line. Okay, so it is basically switching the circuits. That means your line is getting connected to this particular entire circuit. So that is going to happen. The operator is going to give you the access, and then after that you can make a, or you can have a conversation with your destination, and then you can disconnect. So this used to happen in older movies or older times. Okay, even in India, if you had to make STD and ISD calls, I think early 90s probably. So at that time, this is the way it used to happen. Okay, so this is the basic concept of circuit switching. That means if there is some connection that needs to be made between a host and between a source and a destination, then you actually pick a proper path. Okay, you give a proper path for this call to happen, so that one, you get a good quality of service at the end of the day, because you're giving this entire path for this conversation or for this particular communication to happen. Of course, there's no queuing delay, because whatever data you are sending, it is going to go via this path. It does not have to wait for any other data to come in. All right. So you are getting a guaranteed performance with this. You are not sharing with anybody else. Okay. And you can send the data as bits of streams. All right. And there's one more thing that circuit switching can provide, that is a better or a secure way of transmission of data as compared to packet switching. Okay, I'm not saying that it is fully secure. There can be many other ways of intruding, but it is still secure than packet switching, because you are not sharing here. Okay, so if you do not share, then you definitely are not doing a great job. Okay, so therefore basically you are going to waste your resource if there is a sudden disconnection. All right, so what do? We generally try to find out that even with this kind of circuit switching, can we share a bit more with different users, because there are a large number of users. Okay, so this sharing in circuit switching is done in, it has to be done in such a way so that you are sharing the bandwidth, but still you are not intersecting your data with anybody else's, right? So for that, what we can do, we can use FDM, that is frequency division multiplexing. So basically, if you have 4 different users, you can divide the frequency with into 4 different you give the users 4 different bandwidths. So this is how you do this. So you use FDM, you give 4 different bandwidths to these users. So earlier you were giving this entire bandwidth to the user, so that means faster transmission, okay, and better QoS at the end. Okay, but when the 4 users are sharing this entire bandwidth, so that means their share of bandwidth is getting reduced. So it is going to introduce delay, and of course lower QoS at the end user also. So this is the issue, but again you are sharing the bandwidth here. And if you do not want to reduce the bandwidth, you want to give the entire bandwidth to the user so that the QoS should be high, what you can do, you can use time division multiplexing. So that means you are basically saying that each user will be given a particular time within which it can do its communication. So this is how you can basically share the frequency with time for these different users. Okay. All right. So this we have already discussed that, you know, what are the advantages of packet switching over circuit switching, or what is the difference between packet switching and circuit switching. So in packet switching, we do not have any reservation of resources. So the resources are used on demand. Okay, whatever the demand comes from the user side, that is how the resource will be used. Okay, now with this, what will happen if too many resources are being too many resources are being requested by different users, then they have to wait. Okay, they have to wait for access for a communication link because of queuing delay, right? So this introduces a lot of delay. The messages might have to wait to get access to the communication link. And however, even though this happens, because you are sharing the resources, packet switching will allow more users to use the network. Okay. So some of the advantages that packet switching has over circuit switching is that, of course, it does better sharing of bandwidth. It is a very simple technique. Okay, you do not have any complexity of, you know, how much resource to reserve, when to stop. Those questions do not come into picture at all. So it's an efficient technique also, and it is of course less costly. So this is an advantage that packet switching has over circuit switching. It does have certain disadvantages also, and you all know what are those disadvantages. It provides delay, okay, which is of course not accepted, or it is basically not good for the QoS that the user wants at the end of the day. Okay, so these are certain issues. So QoS will be very less. Then you will have different types of delays that will be there. If you know, it is good when there is a lot of bursty data that is coming. Okay, so suppose there is a burst of data that is being sent by the users. Which one will you use, whether it is packet switching or the circuit switching? So think about it. If there is a burst of data and you are using circuit switching, that means for all of the data that is being sent, you have to start creating this circuit. That means you have to reserve the resources and then send this data. And then after that, you have to, you know, again, once the communication is done, then you have to again, stop this connection. Again, you have to start. So this will basically be very cumbersome. Okay, when you use circuit switching for a bursty network. But if it is a packet switching that is used when it is a bursty network, in that case, because you are sharing the resources, nobody has to wait. Of course, they have to wait for due to queuing delay, but nobody has to wait for, you know, creating the resources. Okay, so it is simpler. There's no call setup, etc. However, there can be a lot of congestion that can occur, as I already mentioned, because of delay that is being provided. So if I want to do something better, or if I want to have the best of both worlds, I would like to have some kind of a switching technique that uses both of these. Okay, it has packet switching behavior also, and it has circuit switching behavior also. Okay, so you can have bandwidth guarantees, and you also do not have to probably set up this entire call. Okay, so in the next class, we are going to study about that, whether there are some techniques which are existing which use somewhat, you know, this packet switching and circuit switching ideologies. We cannot totally use, like, there is a circuit switch which uses packet switching because of its the limitations that it has. But we will see that there are two more techniques, that is, one is message switching and one is virtual circuit switching. So with that, we will see that how we can use the idea of packet switching over some circuit switching. Okay, so this is what we are going to study. Of course, advantages of circuit switching and all we have already seen. So let's go ahead. So today we will, I'll stop the class here itself. Now, does anybody have any questions? If you have any